Hello everyone, welcome to Chapter 2 Lesson 3. This is Brianne Pernick for Robert Morris University Math 0900. In this lesson, we are going to work on solving equations that are in the form ax plus b equals c, solving equations that have a variable on both sides of the equation, and also solving equations that contain parentheses. There are no new terms for this section. Everything that we have previously covered is included in this section though, so please make sure that you are familiar with the vocabulary that we've covered so far in chapters 1 and 2. Now, in order for us to solve equations that involve addition and multiplication, we have to use the skills that we learned for solving equations that had only addition and only multiplication. So let's pause for a moment here and think back to what we did when we had one-step equations that were in the form of x plus b equals c, or something like 2x equals c. When you had an equation that had addition or subtraction, we undid that addition or subtraction using the opposite operation. So we always undid our addition using subtraction, and we always undid our subtraction using addition. For the multiplication and division problems, we do the exact same thing. We undo multiplication using division. We undo division using multiplication. Okay? These problems up here were called one-step equations because we only had to perform one step in order to solve for our variable. What we're going to be moving on to now are equations that contain addition and multiplication. So these equations, the ones that are in the form of ax plus b equals c, are often referred to as two-step equations because we are going to need two steps before we solve for our variable. So now that we have reviewed what we covered in the beginning parts of Chapter 2, we can refer back to what we learned when we had only the addition and only the multiplication. And now that we have both addition and multiplication, these steps right here are the steps that you are going to have to follow in order to solve a two-step equation. So the very, very, very first step, which is always your first step every time you encounter any type of equation, no matter what it is to check and see if any terms can be combined or simplified. This is always your number one step. I don't care what type of equation you're solving. I don't care if it's a parenthetic equation that involves parentheses. I don't care if it has fractions. I don't care if it's a one-step, a two-step, a multi-step. You will always check to see if terms can be combined or simplified, because if you can automatically reduce your equation down to fewer terms, then your equation is going to be easier to solve. After you combine any like terms that can be combined, the very next thing that you are going to do is undo any addition or subtraction. After you take care of that addition or subtraction, the last step that you would do is undo any multiplication or division. So let's look at some examples here. Our directions ask us to solve for x and to show all work. So the first thing we do is look to see if any terms can be combined. We have 5x plus 3 equals 18. When we are working on the left-hand side of that equal sign, nothing can be combined on the left-hand side. We have a 5x and we have a 3. When you have a variable term and a constant, they are not like terms. They cannot be combined together. So you must resort to your equation solving skills in order for you to be able to solve that. So step 2 says to undo any addition or subtraction. We have addition of 3, so we have to undo that addition. The opposite of addition is subtraction, so we're going to subtract 3 from both sides. So now we have 5x equals 18 minus 3 equals 15. Next, we will undo the multiplication between 5 and x. So the opposite of multiplication is division. As soon as you say division, you're going to put your fraction bars on both sides of the equation, just like that. And we are dividing both sides by 5 so that we can isolate x. 15 divided by 5 is 3, so x equals 3. Let's take a look at example B. The first thing that we would do is check to see if there are any like terms. There are none. So now we're going to undo our subtraction. The opposite of subtraction is addition. So we must add 7 to both sides of the equation. So 3x will equal 15. Next we have 3x, which is multiplication. To undo multiplication, we must divide. So we will divide both sides by 3 so that we can isolate x. 15 divided by 3 is 5. And we have now solved for x again. Often, you will have equations that have a variable on both sides of your equal sign. When this happens, you cannot solve your equation until you move the variables to the same side of your equation. You can move them to the right or you can move them to the left. That doesn't matter. What matters is that you get your variables onto the exact same side of your equal sign. Now, when we move variables, moving variables is different than undoing them, okay? We just simply want to move them to the other side, essentially so that we can combine like terms. That's what's going on here. And we will always move our variables using addition or subtraction, depending on what you've got going on in your equation. Again, step 1 of every single equation is always to check to see if you can combine like terms first. If nothing can be done, then you have to move your variables to one side or the other so that we can proceed with our equation. So let's take a look at some examples here so that we can see what we're talking about. Letter A, we have 9x equals 6x plus 15. You will note here that we have a variable term on each side of the equal sign. We have a 9x on the left, we have a 6x on the right. We cannot proceed with this equation until our variable terms are on the same side of that equal sign. Now, our goal in every equation is to solve for x by isolating it. So as I look at this equation, I ask myself, which term is more isolated, the 9x or the 6x? Well, 9x is all by itself on the left, and 6x has a plus 15 with it. So obviously the 9x is the more isolated of the terms. So it should make sense to us that we would want to move the 6x over to the left-hand side so that it is with the 9x, since that term is already more isolated. Now, our 6x is a positive 6. Remember that positive numbers are like additions. So to move an addition, we will use subtraction. So we are going to subtract 6x from both sides of the equation. 9x minus 6x makes 3x. On the right-hand side, 6x minus 6x made 0. They cancel each other out, and we're left with a positive 15. So we have 3x equals 15. To undo multiplication, we will divide. So we'll divide both sides by 3 to further isolate our x. 15 divided by 3 is 5. And you have now solved an equation that had a variable on both sides. Now let's take a look at example B. It is very, very similar to example A. Why don't you go ahead, take a minute, and solve this equation. Whenever you're finished, please play the recording and we'll go over the answer together. Okay, at this point you should have had an opportunity to solve example B. In this equation, you will note that there are variable terms on each side of the equal sign. We cannot proceed until they are on the same side. 8x is the more isolated of the terms, so you should want to move your positive 5x to the other side. Since your 5x is positive, you will move it using subtraction. So we're going to subtract 5x from each side. 8x minus 5x is 3x, and that leaves us with a negative 21. Please do not forget that the sign in front of the number belongs to the number, so it must travel down with it to the next line. Next, we have 3x equals negative 21. To undo multiplication, we must divide. So we will divide both sides by 3, and x equals negative 7. Our next example is slightly different than the first two. In the first two examples, I taught you to look for the term that was more isolated. In this example, both sides of the equation contains two terms. Neither is more isolated than the other. So in a situation like this, it does not matter which term you choose to move. However, my suggestion to you is to always move the term that is smaller in value. The reason for this is because it will keep your variable term positive. And if you're anything like me, I don't particularly like to work with negative numbers. I can, and I'll do it if I have to, but I don't like to. So my strategy for problems like this is to keep my numbers positive as often as I can. So what I choose to do is to move the variable term that's smaller in value. We have a 9x and a 7x. Which one's smaller? Obviously the 7x is smaller. So since it was a positive 7, I will move it using subtraction. So I'm going to subtract 7x from both sides. Please make sure that you line the x terms up. Don't try to subtract your 7 from your 3. Okay, it's a variable term, so you must subtract it from the term that it is a like term with. 9x minus 2x 9x minus 7x gives us 2x. And then you're going to bring down everything that you have left over. So we're going to bring down the positive 3, the 7x is made 0, and we bring down a negative 2. At this point, we have a two-step equation. So we have multiplication to undo and addition to undo. You always undo the addition first. So we start by subtracting 3 from both sides, and we have 2x equals negative 5. Then to undo multiplication, we're going to divide both sides by 2, and x is going to equal negative 5 halves, which we would turn into a mixed number, so it is negative 2 and a half. And there's your final answer there. I would like for you to go ahead and try letter D. You're going to solve it very, very similar to what we just did. Please pause the recording, solve the problem, and when you're ready, play the recording again, and we will go ahead and proceed together. Okay, at this point you should have had an opportunity to solve letter D, and you should be ready to check your work with me. Now, I told you before that it does not matter which variable you choose to move. You could have subtracted the 10x, or you could have subtracted the 8x. Either way, you should get the correct answer. It makes no difference. I choose to always subtract the number that has the smaller variable, or subtract the term that has the smaller numerical value to keep my variable term positive. Personal preference. You don't have to do it that way. It's just my choice. So what I do is, since 8 is smaller than 10, I'm going to subtract 8x from both sides. 10x minus 8x is 2x. Bring down your positive 5. Bring down your equal sign. Bring down your negative 3. You now have a two-step equation. We have 2x plus 5 equals negative 3. At this point, we want to undo the addition. So we will subtract 5 from both sides. And that leaves us with 2x equals, when the signs are the same, you keep the sign and add the number, so we have negative 8. Undo multiplication by dividing. That isolates x. Negative 8 divided by 2 is negative 4. So x equals negative 4. The next example that we have here requires us to combine like terms before we begin. Remember that that is always step number 1. Combine like terms when possible. So looking at the left-hand side, you should see that you have constants that can be combined. So we have 5x to bring down, and 26 minus 6 makes 20. So I'm going to bring down a positive 20. Bring down my equal sign, and on the right-hand side, 9x and 12x are like terms, so they can be combined. 9x plus 12x makes 21x. The next thing we have now is the step where we would want to get our variables on the same side of the equation. So we want to go ahead and move the one that has the smaller value. You will also notice that the 21x is also the more isolated of the x's, so it makes more sense to go ahead and move the 5x over there. So we're going to go ahead and subtract 5x from both sides. And we have 20 equals 21 minus 5. which gives us 16x. At this point, we are going to go ahead and divide both sides by 16, and x will equal, as you look at your fraction of 20/16, you may notice that that can be reduced by 4. So the 20 becomes a 5 and 16 becomes a 4. So now we have 5/4. Turning your improper fraction into a mixed number, that will be 1 and 1/4. And there is the final answer. Letter F is very similar. Please go ahead and take a second and solve letter F. Pause the recording, and as soon as you are ready, please press play, and we will review together. Okay, at this point you should have had an opportunity to solve letter F, and you should be prepared to review the final answer with me. On the right hand side, you should see that you have like terms, or excuse me, on the left hand side, you have like terms that can be combined. We have 7x and negative 2x that we can combine together. 7x minus 2x makes 5x plus 2 equals 12 plus x. As you're analyzing the next line of this equation, since you do not have a variable term that is isolated per se, you should move the one that has the smaller value. So we'll move our 1x. So we will subtract x from both sides. 5x minus 1x makes 4x plus 2 equals 12. We now have a two-step equation, so we're just going to go ahead and follow those rules that we learned earlier and undo the addition first. We undo addition with subtraction, so we're going to go ahead and subtract 2 from both sides. 4x equals 10. Divide both sides by 4. I'm going to go ahead up here. X equals 10 over 4, which is a fraction that we can reduce. We can reduce this by 2, and it will become 5/2. We don't want to leave our fraction as an improper fraction, so we're going to go ahead and turn that into a mixed number, and it does become 2 1/2. The last objective in this lesson is for us to be able to solve equations that contain parentheses. So now we're going to start to combine the distributive property as well as the order of operations into our equations as we're solving down. So it becomes extremely important for you to make sure that you have understood the lesson on grouping symbols, distributive property, order of operations, plus everything that we have done so far in order for you to be able to successfully complete the equations that we're about to work on right now. We're now going to take a look at some examples and work our way through. In the first example, we have 4 times the quantity x plus 1 minus 3 times the quantity x minus 3 equals 25. You are simply going to start with the order of operations on each side of your equal sign. Since the right-hand side of our equation only has a 25, we're not worried about it. We're going to look at the left-hand side. So we need to remember our order of operations. We have our parentheses, exponents, multiply, divide from left to right, and add, subtract from left to right. So the first thing that we want to do is anything inside our parentheses. We cannot do the addition of x plus 1. or the subtraction of x minus 3 because they are not like terms. We learned, however, that in a situation like this, we can remove parentheses by using the distributive property. So at this point, we're going to go ahead and distribute in the 4 using the distributive property. So 4 times x makes 4x. 4 times 1 makes positive 4. For my other quantity, I am distributing in a negative 3. So the negative 3 will get multiplied to every term inside that parenthesis. Negative 3 times x makes negative 3x. Negative 3 times negative 3 makes positive 9. And then I will bring down my equals 25. After you distribute, you want to check to see if you can combine like terms, which we can. So we will combine our 4x and our negative 3x. 4x minus 3x makes 1x. And then we can combine our positive 4 and our positive 9. 4 plus 9 makes 13. And then bring down the equals 25. We now have a one-step equation, and we can go ahead and solve that by undoing the addition. So we will subtract 13 from both sides, and x is going to equal 12. Let's take a look at example B. Always look to see if anything can be combined. Look for your order of operations. Inside your parentheses, you cannot do anything, so you must rely on the distributive property in order to help you simplify. So on the left-hand side, we will bring down our 11 and we will distribute a negative 1. Please remember that what's directly in front of the parenthesis is what gets distributed in. So we will do negative 1 times 6x and negative 1 times 1. So that will make negative 6x and negative 1. On the right-hand side, we will bring down the 5x and we will be distributing in a 2. Negative 2 times x gives us negative 2x. Negative 2 times 4 gives us negative 8. After you distribute, you must always combine like terms. On the left-hand side, we'll bring down our negative 6x and combine our constants. So 11 minus 1 makes positive 10, so we write plus 10. On the right-hand side, we can combine the 5x minus 2x to make 3x, and then bring down the negative 8. At this point in the equation solving, we need to get our variables on both sides of the equal sign, since we have a negative 6x on the left and a 3x on the right. We cannot go any further until our variables are on the same side. You can choose to either move the 3x or the negative 6x. It makes no difference which one you choose. As I've mentioned, my preference is to always move the variable that has the smaller coefficient. I do this because I like to work with positive variables whenever possible. This is something that I can control. So I'm going to move my negative 6x. So to move a negative, we will use a positive 6x, and we will add that to both sides. Those make 0, and we have 10 equals 9x minus 8. We now have a two-step equation that we can solve. The first thing that we need to undo is the subtraction. we undo subtraction with addition. So we will add 8 to both sides. 10 plus 8 is 18 equals 9x. Divide both sides by 9, and x equals 2. At this point, I would like for you to go ahead and solve problems C and D. Pause the recording, solve the problems, and when you're ready, play the recording and we will go over the answers together. Okay, by now you should have solved both problems C and D, and you should be ready to go over the answers with me. On the left-hand side, you should have found that there was no combining that you can do within your parentheses, so we do need to distribute in a positive 3. 3 times negative x makes negative 3x. 3 times negative 7 makes negative 21. On the right-hand side, since there was no combining that could be done inside the parentheses, we will distribute in a negative 2. Negative 2 times 2x makes negative 4x. Negative 2 times 5 makes negative 10. We now have an equation that has variables on both sides of the equal sign. The strategy here needs to be to get the variables on the same side by moving one. You could have chosen to move whichever variable you wanted. It makes no difference which one you move. I chose to move the negative 4 to the other side because it was the one that had the smaller coefficient. So I will add 4x to both sides, which cancels out that term right there. So 4x minus 3x makes 1x minus 21 equals negative 10. You now have a one-step equation that you can work on. You will undo subtraction by using addition, and we will add 21 to both sides. 21, not 211, sorry. 21 take away 10 is 11, and that gives us x equals 11. For example D, neither quantity you cannot combine like terms in either quantity, let's say it that way. So you must rely on the distributive property in order to remove your parentheses so that you can move forward. So on the left-hand side, we will distribute in a positive 5. 5 times 2 makes 10. 5 times negative x makes negative 5x. On the right-hand side, we'll bring down our 8, and we will be distributing in a negative 1 to that entire quantity. Negative 1 times 3 makes negative 3. Negative 1 times 6x makes negative 6x. Check to see if you can combine like terms. We can. On the left-hand side, we cannot combine like terms, so we will simply bring every term down. But on the right-hand side, we can combine 8 minus 3. 8 minus 3 makes 5, so we'll simplify that. And now our equation looks much better. We have an equation that has variables on each side. We need to get one of our terms onto the other side. You could have moved either one. It makes no difference. I chose to move the negative 6x because that coefficient had the smaller value. By moving that, my variable term stays positive. So I'm going to add 6x to both sides. So bring down my 10. 6x minus 5x makes positive 1x. Bring down my 5, and then my x is canceled, so I have nothing further left. You now have a one-step equation. Now your 10 is a positive 10. Always look for the sign in front of the number to determine what operation needs to be done. So we need to subtract 10 from both sides. X equals negative 5. This completes our lesson on section 2-3. If you have any questions or concerns about this lesson, please feel free to contact me and I will be more than happy to work with you and help you master these concepts. Thank you and have a great day.